So here is Roberto Santos, and now we are moving to the second phase. In the first two videos, we went through the slides talking about HydroML and how we developed integration between Belize surface system with HydroML. Now we're going to talk a bit more about HydroML itself, how we upload data, how we create projects, how we upload data, and then how we move to configure these datasets and run training models, assess the quality of those trained models, and use the web interface here to do a quick check by running a small prediction. Okay, so I'm running locally, so HydroML it's an open source tool available on GitHub, and all users are more than welcome to download and install them on your local computers or in your infrastructure for use. Okay, so here we have, I'm gonna log with my user. I do have here a couple of test projects that I don't have created before. I'm gonna create a new one. Okay, so this is gonna be my I'm gonna call this station Valparaíso. Okay, uh, and this is my um, no existing hydrological station for training purpose. Okay, so the first big decision that we need to take to make about the project is what type of project you have. Is this a rainfall or a water level project? Okay, so HydroML as it is now supports those two types of data, rainfall and water level. Behind the scenes we have two different machine learning model techniques running, one for each type. And for this first step I'm going to use the rainfall. Okay. Then we need to decide what is the format or what delimiter we are using in the file that we are going to be using to upload the training model. So we support the standard basic CSV files with data split by commas, dot commas, tabs, and spaces. I'm going to use the standard comma here. And then you choose the data file set. Okay. I have downloaded these files before, and I'm gonna quick show you an example. This is not important. Um, let me show. Let me show you what we have here. So if you look at the rainfall data, it's composed of a number of columns split by commas. Okay, we usually have two main columns. One is the timestamp, and we have here, it's the first column called date time with the timestamp of the measurement. And for the training, it's very important that you have the label column, that's the last one. So remember, the training model is the one where you provide the readings, the measurements, and you say this is a good reading or this is a bad reading, a good reading or a bad reading. Okay, and you can see that on this data set, on the beginning of this data set, I'm just showing you the header of this one, like the first 10 rows. We have many ones, and we have an exception here. This reading, this measurement that we are classifying as 0. Okay, and you can see that it varies in numbers very when you compare to the other columns, to the other rows. So reminding you that rainfall uses the random forest machine learning method. Okay, and the approach here is we are trying to train a model to classify the quality of data in a particular data station using the values, the measurements of the stations around this one. So that's why you see that we have one column for a station called Central Farm, one for Chalk Creek, one for Hawksworth Bridge, and one for Santa Helena. Okay, we have another column here called AVG for average. That we are going to ignore this column. We are going to have in a second. We are going to show you how we are going to be identifying these columns in the process, which ones we're going to be using, and which ones we're going to be ignoring. Okay. Uh, so, okay, so that's the data we have. I'm gonna choose rainfall data here. Gonna open, gonna hit next, and the next step is choosing the hyperparameters. Okay, so rainfall data is using random forest, and there are two main parameters that we need to define when using a random forest algorithm. One is the max number, the max depth. Okay, so it's a method based in trees and trees decision trees, and those decision trees they can grow in depth as much as we want. We usually try to look for a balancing between this depth and so that we have a model that is super accurate but might be overfitting for a particular training set, to a model that give us good results but is generic enough to be used for new data, not just for the training data sets. And we also have to define the number of estimators. Okay, so I'm gonna keep the default ones here, 4 and 100. I'm gonna hit next, and the next screen we have the columns that we have in the CSV file, and then I need to identify what is what in this set of columns. So the first one is the date time. I want to make this my timestamp. So every data set needs to have a date. Training data set must have a date time. Uh, I need to choose which ones are my input columns, my input filters. Okay, and I'm going to use all stations as input filters. So Central Farm, Chalk Creek, Hawksworth, and Santa Helena. Okay. Uh, the average column we don't want to use in this training model, so I can just skip it by default. And we define which one is the target uh, feature or the target column in this data set. So which one identifies to the model in the training phase if this is a good or a bad data. And this is the label column. Okay. Just for curiosity, label is based on the values of Hawksworth. So we are training a model to classify the values of the Hawksworth Bridge station, and we are going to use as inputs for this model the values of the Hawksworth in itself plus other three stations that exist around this station Hawksworth. We are going to hit save, and now we have our station Valparaíso, and we can see quickly here the data set. We have a chart with the data set. We can visualize this data in a table format. We can revisit the features, and so if I want to change anything from that first definition of my features, I can do it here. I can revisit my hyperparameters. I can check my labels, and labels are very interesting because labels are basically a lookup table between those good and bad values that we have from the model and the quality flags that we have in the origin system. In this particular project, we are talking about the quality flags from surface, the Belize meteorological system. And then we have the models, the tab models. Because I just created this project, we don't have any models at the moment, but I can just hit here, train model. I'm gonna see the hyperparameters. I could change them here on the last minute and make a new adjustment. I can change the sequence of features or the type of features that I have in this data set, and I can start training. Okay. I get a message saying that the training has started. training of the rainfall data is fairly quick. It only relies on the size of the training data set, but usually we train a model with a few thousand rows in less than a second. Okay, and then we have the results of this training model. We can see that the training was successful. On the left side, we have an ID for this model, and this is going to be important for reference when we do the integration with the surface, because surface needs to know which model. So the HydroML needs to know which model surface wants to use to predict some data. We have some information about the duration of the training. It took less than a minute. It was really a couple of seconds. We have some columns with metrics such as accuracy, precision, recall, F1 score. We do have here the confusion metrics. That's basically showing how many times we the training model found that a bad value was really a bad value compared to how many times it found a bad value and classified this as a good value, or vice versa. So keeping an eye on the confusion metrics can give us a fairly good idea of how the model is behaving in terms of being overfitting or being generic. So we want to always find a sweet spot in between too much generic or too much overfitting. It tells us what hyperparameters we use in this particular model, what were the input variables, input columns, who was the target column, and which ones we skipped. Okay, we can download this model. And this is a serialization using Pico, the Python library for serialization. We can delete the model. I can train a new model here. Let's say now I want to play with, let's say, max depth equals 6. And this is going to run a new model. We can see that this is in the training status. The ID is 17 now. And if I just change screens, I can see here that now I got a new model. So during the integration phase, I can choose which one of those two I want to use for my for the prediction. I hope that you are following me so far. If you have any questions, please comment below the video. And in the next video, we are gonna use this function here, prediction, to make a prediction about using these models. Thanks a lot, and see you in a bit.